Welcome class, and thank you for joining me for our final notes video for chapter 10. You've made it. So, today we're going to continue talking about radical equations. However, we are still going to begin by reviewing for finals. So, our first review is to graph these set of points and decide what model is appropriate for the given set. So we need to graph these points. So -6, -1 is going to be right about there. -3, 2 is going to be right about there. -1, 4 is going to be right there. Then 2, 7 is going to be right there. So looking at the points that I just plotted, if we connect them, you can clearly see this is going to be a very straight line. So the model that is most appropriate for this data is going to be a linear model. Now, just as a reminder of what the others would look like. So we have three types of models. Linear, we've discussed, just makes a straight line. Quadratic, hopefully you remember, quadratics make that parabolic shape. Exponential, which are created by multiplying, start slow, but then begin to increase rapidly. All right, so jumping into the new material for today, we're going to continue solving radical equations. However, now we're going to be dealing with extraneous solutions. Now, these are solutions that don't solve the original equation. And I'll explain what that means in just a moment. Now, in order to solve these radical equations, you actually do exactly the same process at the beginning. First thing you want to do, you want to isolate the square root. So, in looking at this example, the square root is already by itself. So, because it's already by itself, I'm going to square both sides. So, in squaring both sides, I'm going to get x squared equals, and now squaring a square root just undoes the square root and gives me back what was inside. So I'm done with my first step. I've squared both sides of my equation. Now, moving into the second step, because it is something quadratic, that means our method of solving is just to get it set equal to 0. So I'm going to add x to both sides and subtract 6 from both sides. So over here, I'm going to have x squared plus x minus 6, and I canceled everything on the other side. So again, I just moved everything together to get it set equal to 0. Now that we have a quadratic, you guys should know that this means we are going to now factor in order to solve it. So we get our x's, and now multiplies to -6 and adds to 1. We're going to get a +3 and a -2. All right, so I'm done with my factoring step. Now I'm moving into my solving step. So now I take each of those parentheses and I set them equal to 0. So x equals -3 and x equals 2. Now, let's go back to the original equation. So we're talking about -3 and +2. Now let's go back to this original equation. Now, something that we've briefly touched on before previously is you cannot take the square root of negative numbers, okay? And you will also never take a square root and have it equaling a negative number. So these extraneous solutions, these solutions that don't actually solve the original equation, those happen when you plug in an x value that would set a radical equal to a negative number. So when we're talking about x equals 2, and x equals negative 3. Well, notice if I plug that in, I'm going to have a radical that set equal to a negative number, okay? And in math, we don't allow that. That will not solve this radical equation. So because your radical would be set equal to a negative value, we say that is not a legitimate solution. It does not solve the original equation that started this problem. So that's why we say that negative 3 turns out to be an extraneous solution. So we're going to be moving on to the next page. So pause the video if you need a little bit more time to write. But let's move into our next example. So looking at this, we are going to be squaring both sides. The radical is already by itself, so let's square both sides. So negative y squared. Well, remember that squared cancels out the negative, so we just end up getting a positive y squared and the square undoes the square root. So that's our squaring piece. Now let's move into getting it set equal to 0. We have a quadratic, so we're going to get it set equal to 0. I'm going to subtract y from both sides and subtract 6 from both sides. So over here we get y squared minus y minus 6 equaling 0. Now that we have a quadratic that is set equal to 0, now we can begin our factoring process. So to factor this, we're going to get our two parentheses, our y's. Now we need it to multiply to negative 6 and add to negative 1. So this time it's going to be a negative 3 and a positive 2. So we're done with the factoring step. Let's move into our solving step. To solve this, like you've seen so many times before, set both equal to 0 and solve. So you get y equals 3 and y equals negative 2. So let's take a moment. Let's go back and think about these. So we have two solutions, y equals 3, y equals negative 2 that we are considering. Now, this time we have to consider we are plugging into a negative y. So what that is going to mean is when I put in 2, or sorry, when I put in negative 2, if I do the negative of negative 2, it's going to become positive. So that'll actually be okay. The radical will be set equal to a positive number if I actually use negative 2. However, let's say that I'm trying to plug in that 3. Now, this is setting my radical equal to a negative number. Because it is a negative y out there, plugging in 3 this time is resulting in setting my radical equal to a negative number. So, because of that, once again, we actually have to cross off one of our solutions. It is an extraneous solution. one that does not actually solve the original equation. So, jumping to our last page, so we get a little reminder on how to do all these. So, let's work on solving these. So, here, we're trying to isolate the square root. So, by isolating the square root, we need to subtract this 6 off. So I'm going to subtract 6 from both sides. So I get negative square roots of 2x equals 4. Now, I'm going to divide by that negative 1. I want to get that negative away from my square root. All right, now we have a dilemma here, okay? Now, our dilemma is we have a square root that is set equal to a negative number. Now, we just finished having that conversation saying that we actually don't know, or we can't do that. We can't let a square root equal a negative value. So we're actually going to call this a no solution. We don't even have to finish solving this problem, because once we hit the point of having a square root that is equal to a negative number, we can be done. We know there's nothing more that we can do. So let's take a look at this one. I'm going to subtract 7 from both sides. Our first goal is to get the square root by itself. However, when we do that, notice what just happened. We ended up with that same situation. We have a square root that is set equal to a negative number. So when this happens, we can immediately end our process. We don't have to continue solving, because there is going to be no solution for this problem. That's the end of our story. All right, and finally, let's do one last one together before we end this note video. So, the radical is already by itself, so I'm going to square both sides. So we have x squared equals that. Remember, squares and square roots undo each other. Now, we have a quadratic left. Our method for solving quadratics is we need to get everything to one side. So I'm going to subtract off that 17x, and I'm going to add 70. So we end up with x squared minus 17x plus 70 equals 0. So now we need to finish solving this. We need to factor this. Well, in factoring this, it looks like we are going to get x minus 7 and x minus 10. So when we go and solve each of these pieces, so I set it equal to 0 when solve, so I get x equals 7 and x equals 10. Now, looking back, so remember, we always have to check these. Looking back at our original problem is actually exciting, because notice that no matter what, if we use 7 or if we use 10, our square root is both times being set equal to a positive number. So this time we actually don't have to worry about an extraneous solution, because plugging it in, both are giving us positive numbers. So both actually end up being okay in this instance. All right, so thank you so much for joining me. So please make sure you have all of this written down, and so you can come back to class prepared to do our practice work to end off this chapter.